Hello listeners, welcome again to my page. In this video, we're going to be looking at some mathematical question that involves absolute values and inequalities. Absolute values and inequalities. In the first example we'll be looking at, we want to determine all x elements of a real number such that absolute value of x minus 1 all over x plus 1 is less than 1. Okay. Solution. Now, there is a trick for solving questions that has to do with absolute values. The trick is that the absolute value of a could be a when a is greater or equal to 0, or it could be minus a when a is less than 0. So every absolute value must be separated. Let's write it. Every absolute value must be separated into two cases. A case where a could be greater or equal to 0, or a case where a could be less than 0. In a case where a is greater or equal to 0, the absolute value of a will be equal to a, that is positive a. But in a case when a is less than 0, the absolute value of a will be equal to negative of a. So with this in mind now, we can now apply this logic to solve this problem now. So we have case 1, we can separate it into case 1. Case 1 is when x minus 1, which is this absolute value here. This is the absolute value we are considering now. We are considering when x minus 1 is greater or equal to 0. That is, x is greater or equal to 1. So in this case now, the absolute value of x minus 1 will be equal to x minus 1. It will be equal to positive x. Positive. This is positive x minus 1. Okay. This is case 1. So we'll now solve with respect to this case now. So with respect to this case, the absolute value of x, this question will now turn to x minus 1 all over x plus 1 less than 1. Okay. Now we're going to subtract 1 from both sides. Subtracting 1 from both sides is going to be x minus 1 all over x plus 1 minus 1 less than 1 minus 1. So we're subtracting 1 from this, the sides, both sides of these inequalities. So having done that, we're going to have x minus 1 all over x plus 1 minus 1 less than 0. Of course, this cancels out to give us 0. So the next step we're going to take is that we're going to rewrite 1 to have a denominator of x plus 1. You know that 1 is equal to x plus 1 all over x plus 1. So we're going to just substitute it so that we can have the same denominator. So that it will now be, okay, yeah, because, okay, let's put it because 1 is equal to x plus 1 all over x plus 1. So we're having x minus 1 all over x plus 1 minus x. We are replacing this one now. We're replacing this one with x plus 1 so that we can, it will be easy for us to compute. X plus 1 all over x plus 1. So simplifying this now, we're going to have x minus 1 all over x plus 1. They all have the same base, so we have x plus 1 as the same base. So we have x minus 1 minus x plus 1 less than 0. We are simplifying the numerator here. We are going to have x minus 1. Yeah, so this minus 1 will multiply x to have minus x. Then minus 1 multiplying plus 1, we're going to have minus 1 all over x plus 1. Yeah, so we know that this is plus x is going to cancel out minus x, so that what we have remaining will be 2. So minus 1 will give us minus 2 all over x plus 1 or less than 0. Note that we are looking for the negative value of x, since the inequality sign shows less than 0. That is less than 0. So it means that it has to be in the negative side. Also note, since minus 2, that is the numerator, is already negative, the whole fraction will be negative when x plus 1, when x plus 1 is greater than 0, that is a over b must be opposite signs for the whole fraction to be negative. That is, if a is negative, then b must be positive. So what we now have is x plus 1 is greater or equal to 0. That means x is greater than 1. So this is what we'll have in our first case. X is greater than 1. Then in our second case now, in our case 2, in case 2, x minus 1 is less than 0. That means x is less than 1. So therefore, the absolute value of x minus 1 will be equal to minus x minus 1. Minus sign multiply x is going to give us minus x. Minus times plus minus 1 is going to give us plus 1. So this is, matter of fact, going to be 1 minus x. It means the same thing. Minus x plus 1 is the same thing as 1 minus x. So this is going to now be 1 minus x all over x plus 1 less than 1. That is what our equation we are considering. The equation we are considering will now turn to this. So we're going to now subtract 1 from both sides of the equation, so that we'll have 1 minus x over x plus 1 less than 0 minus 1 is less than 1 minus 1. Having 1 minus x over x plus 1 minus 1 is less than 0. Yeah, but 1 is x plus 1 over x plus 1. So we have to substitute it. That will now have 1 minus x over x plus 1 minus x plus 1 over x plus 1 is less than 0. Combining the fraction gives us x plus 1. It will have the same base, so that we'll have 1 minus x minus x plus 1. Yeah, till less than 0. Further simplification, you're going to have simplifying the numerator. You're having 1 minus x minus times x is going to give us minus x, minus times plus 1 is going to give us minus 1 all over x plus 1, still less than 0. Automatically, plus 1 is going to cancel out minus 1, so that We are now left with minus s minus x is minus 2x all over x plus 1 still less than 0. Again, since we are looking for the negative value of x, that is less than 0 now, minus 2x greater than 0, that is x less than 0, that's when we divide by 2, or let's make it simpler, that is we're going to divide by 2, dividing both sides by 2, and then we're going to have x. Dividing by 2 flips the inequality sign. It flips the inequality sign to be x greater than 0, x greater than 0. Then that is for the numerator. Then for the denominator, x plus 1 greater than 0, that is going to be x minus x greater than minus 1. So what we are saying is that for this whole equation to be negative, both the numerator and the denominator are going to have different signs. They're going to have opposite signs, just like we have here. For the numerator, x is less than 0, but for the denominator, x is greater than minus 1. So in all the cases, both case 1 and case 2, the combined solution is going to be minus 1 to 0 union 1 to infinity. These are all the solutions of this inequality. Okay, thank you for listening. Till next time, bye.